Welcome to the world of microcontrollers. Today, we will learn about a special one called the 8051 microcontroller. Think of it as a very small computer on a single chip. Intel first made the 8051 in 1980, and it quickly became popular. The 8051 is an 8-bit microcontroller, meaning it works with data in 8-bit chunks. It is the heart of many embedded systems found in devices like washing machines and remote controls. Its simple design makes it easy to understand for beginners, and many universities use it to teach students. The 8051 provides a great starting point with many available resources. It is also used in many real products due to its low cost and reliability. It can control motors, read sensors, and display information. Understanding the 8051 opens doors to bigger things. Let's begin our chibi adventure into its parts. At the core of the 8051 is its brain, the Central Processing Unit, CPU. The CPU reads instructions from memory and performs actions based on them. It controls all other parts of the 8051. The 8051 also has random access memory, RAM, for temporary notes. RAM is like the 8051's scratchpad, storing data that changes often. This makes the CPU work faster and more efficiently. RAM in the 8051 is usually quite small, often 128 or 256 bytes. This might not seem like much, but it is enough for many simple tasks. The 8051 is designed for specific control jobs and does not need gigabytes of RAM like your computer. RAM is volatile memory, meaning it needs power to keep its information. If you turn off the power, RAM forgets all the temporary data. This is why programs are not stored in RAM. It is only for data needed while the 8051 is active. The 8051 stores its program in flash memory, which is non-volatile. This means it remembers its contents even without power. When you turn the 8051 on, the program is still there, like a permanent instruction book. The CPU reads these commands one by one from flash. The size of flash memory in an 8051 can vary, with common sizes being 4 KB or 8 KB. Now, how does the 8051 talk to other devices? It uses a communication module called UART. UART stands for Universal Asynchronous Receiver Transmitter and is used for serial communication. Serial means data is sent one bit at a time, unlike parallel communication, which sends many bits at once. Using UART, the 8051 can connect to a computer, send data for display, or receive commands. The 8051 can also use UART to talk to other microcontrollers and sensors. UART needs two main wires, one for transmitting, TX, and one for receiving, RX. It is a very useful feature for debugging and interfacing. The 8051 has other important built-in helpers: timers, ports, and interrupts. Timers and counters are useful for controlling time, like making an LED blink every second. A counter can count external events like button presses. Most 8051s have at least two timer counters. Input-output ports, I/O ports, are the 8051's way to interact with the world. Through output ports, the 8051 can control things like LEDs and motors. Through input ports, it can sense things like switches and sensors. The 8051 typically has several I/O ports like port 0, port 1, port 2, and port 3. For urgent tasks, the 8051 has a feature called interrupts. An interrupt is like a special signal that tells the CPU to stop its current work and attend to the urgent task. Once the interrupt task is finished, the CPU returns to its previous work. Interrupts can come from timers or external signals via I/O pins. They make the 8051 very responsive and efficient. What if the built-in memory is not enough? Some 8051 applications need more space. They might need more RAM for data or more flash for a larger program. Many 8051 variants can connect to external memory chips, adding more RAM or ROM. This capability makes the 8051 more flexible. To use external memory, the 8051 uses some of its I/O ports as address and data lines. This allows for much larger and more complex programs. So, why is the 8051 still important today? It is a fantastic learning tool. Its architecture is relatively simple to grasp, helping students understand fundamental microcontroller concepts. Learning the 8051 builds a strong foundation for understanding advanced microcontrollers. There are many low-cost development tools and a huge amount of documentation and example code available. The 8051 is not just for education, it is still used in many embedded applications. Its reliability and proven track record are valuable. Many derivative microcontrollers are based on the 8051 core. The legacy of the 8051 continues to influence the world of electronics.